Hi everyone. So today I want to speak about something that I really like. It's application. And when I tell application, it's any kind of apps. It's mobile apps, but also desktop application. And there is also something else that I really like. It's video games. That's why I created this software. It's called GDevelop, and it's an open source and cross-platform game creator that people can use to create any kind of 2D games. And anyone can use it because it's based on a visual editor that people can use to create the levels of the game, as well as some kind of visual programming that I will show just after. And at the end, games are outputted as HTML5 games. So that's how it used to look like. So it's a screenshot of the old version of the application. So it's a desktop application working, which was built using C++, using a toolkit called WX widgets that enables you to create cross-platform visual interface on Windows, macOS, Linux. And I'm gonna make a small demonstration where you see the button that is on the stage of the game. I want that when the player is stepping on the button, then the platform that is on the right is going up in the air so that the player can continue in the level. So to do this, I'll show how to use the events that are the visual programming I was speaking about. So I'm putting the button on the stage, going to the events, and adding an event. So events are conditions and actions. So the condition here will be if there is a collision between the player and the button. Then I will launch two actions. It's like a if-then. So action will be, the first one will be an action to change the animation of the button so that we go from the state where it's pressed, where it's not pressed, to the state where it is. And then another action to move the platform up in the air so that the player can go on it. So I'm adding a force so that it's moving on the y-axis up to move up. And then I can press play. The game is compiled in JavaScript, and now I can play to it, and it's working. So it's pretty simple, and using these rules, people can create games, and they have been creating quite a lot of games using it, so pretty happy about it. But at some point, the editor was getting quite old. I mean, I had lots of cross-platform issues with the UI toolkit. The support for macOS and Linux was really bad, actually, and iterating on the software was slow. C++. Building UI was slow, and I was limited to old UI components. And honestly, the UX would need some great enhancements to be better. And the entry barrier was quite high for new people, C++ again. So I was like, it's time to React. And maybe web technologies could help me, because I've been doing a lot of React and React Native for a while, and I was like, okay, that seems to be a better way of making interface compared to the old imperative way of creating interface. Even with some visual builders, you could not reach the modularity of React. So React seems to be perfect for making complex UI. Or is it really? Can we have, for example, a list of trees of hundreds of elements, dynamic panels, 3D visualization, nested dialogues, drag and drop search, and tons of other things that make the app feel like a real application, either on mobile or on desktop, something that feels like a real application and not just a good website. So in a way, can we make ambitious application? And same question for JavaScript. It's perfect for most applications, or is it really? What if we have an already existing native code base, or have advanced simulation computation, or need consistent performance? Let's take a look. Let's take a look at the code base of GDevelop. It was all C++ code base, and at the core of the code base, there is all the core classes that define what a game is, what is an object, what is a stage on a game, and there were the game exporters classes, meaning that it's all the tooling that take your game and output the JavaScript, the HTML5 game that can run in your browser or on mobile. That's the first part. And on top of it, there was all the graphical user interface, still in C++, and everything related to the file system to write files. So my idea was I could replace the interface by React. And for the file system, I could use Node.js or some browser adapters. meaning that I will be running on Node.js or Chrome or Electron to have an application that I could package and distribute as a classical application that one can download. What about the center of this code base, the C++ code base? Well, that's where maybe WebAssembly could be useful. So WebAssembly, it's a low-level language that is available in most browsers. Actually, if you look at the compatibility, for the most part, it's running everywhere, including in all majors, browser on desktop, and even on mobile. The idea of WebAssembly is that it's a low-level language that is easy to optimize and to run at quasi-native speed. And it's not a language that you write directly, but you write, it's a compilation target. That means that, for example, if you want to write WebAssembly, you can use Emscripten, which is what I've been doing to compile C++ or a C code base to WebAssembly. You could also use language like Rust that are designed to have a compilation target being WebAssembly, and even things like assembly script. I've never tried, but that seems really interesting. It's a TypeScript-like language that compiled to WebAssembly. So it's, I guess, a good idea to try it if you want to give WebAssembly a try. I'll speak mostly about Emscripten because that's what I've been using. The idea is that if you want to use Emscripten, basically you download the SDK, install it, activate it, and then it provides you with a compiler that is a drop-in replacement for GCC or Clang, which are the two major C++ compilers. And instead of running the compilation of your whole project using GCC or Clang, you're using EMCC. And at the end, you'll get, hopefully, if nothing breaks, you're getting the WebAssembly module. Then we have this module, that's fine, but we want to be able to use it on the JavaScript side. So we'll have to expose existing classes. Let's see how to do it. So the idea is that I have here an objects container that's basically a list of objects, like the list that we've seen on the right. And I have a layout, that's the stage of a game. So we can have a name, we can set the name, get the name, and it's inheriting objects container, meaning that it has a list of objects. So starting from this C++ class, we can write some binding. So here I'm using WebIDL. It's one solution when you're using Emscripten. If you're using Rust or other language, there should be a way to do bindings. But the idea is mostly the same. You create an interface that describes the methods of your class. And then Emscripten will be generating some glue code, so one C++ file and one JS file that will expose to the JavaScript world what are the classes that you can instantiate and what are the methods that you can call on them. And when it's called, then it will call the WebAssembly method. So let's see how to use it. Once you have it compiled with the bindings, you get a module that you can instantiate, and then as a result of a promise-like, you're getting the module that I've named GD here, and you can start create classes, call method on it, and it's working mostly like a classic JavaScript class, and it's because the binding are doing things for you automatically. So for example, the primitive types are converted automatically from number to float or double or other primitive types in C++. Same for the strings. And if you pass an object, then the object reference will be converted to a pointer or a reference in C++. And if you want to debug, you'll see that automatically it's done by Emscripten too. The output of the C++ code is returned to the Chrome debugger. So that means that you can run this in, for example, Chrome and get something that is working in the debugger. So that's pretty great, because by doing this, you've been able to reuse your existing code base or a new code base written in another language and run it here in a JavaScript engine. So it's V8, could be another JavaScript engine, could be on mobile. But again, here I'm on desktop. So a few things to know. Memory management requires care, because when you're creating a new object, you have to destroy it later. So why? It's interesting. If you see at the layout here, it's an object, an Emscripten object, and it has a pointer, which is a number pointing to the area in memory where the object is living. So there is the WebAssembly memory. It's a big array, more or less. And inside, there is this object that was created. Then, if you drop the reference to the JavaScript object, then this memory will be retained and will live there forever. So basically, you have a memory leak. That's why you have to be careful about it and to call the destroy method from your module on the object so that this memory is erased. So that's the first thing. And for React, that means that, for example, when you mount a component, you have to, if you create an object, make sure to unmount it when make sure to destroy the object when you unmount the component. Or you can use an effect hook. Another thing to know is that the bundle will be quite large. For example, it's 3 megabytes for gdevelop. It was even worse before. So that's a lot, but honestly, I don't care. I don't care because I'm making an app, so it's okay if the user is waiting for a few seconds while the whole thing is being downloaded. And as I'm packaging the whole application using Electron, it's already 100 megabytes, so one more, one less, the same. Last thing to know is that a complete test set is really useful when you're working with WebAssembly, because that's the kind of errors that you'll get if something is going wrong in the WebAssembly world. So that's not useful at all. And what can go wrong, actually, for example, if you pass the wrong type of parameter, or you forget a parameter, then the method on the WebAssembly world will see, OK, I'm expecting an object, I got past a number, so the number must be the pointer to the object, but it is not, and then bad things will happen. You can also sometimes use a deleted object. That can happen really easily if you create an object, then destroy it, but somehow you still have a component down in your tree of components that is using the object, and then same thing again, you're accessing memory that has been released, so you'll get these errors. But if you know this, then you are able to take an existing code base and move it to WebAssembly, meaning that you have a library that can be reused from JavaScript. The next step is, OK, we have this, we have the core of the software running in a browser or a JavaScript engine in general. Can we use React to make a better interface than what we had before? So let's take a look. We want to make something that is quite complex in terms of interface. So when I say complex, I mean things like context menus, nested dialogues, and a list of objects, color pickers. So things that are going a bit beyond the usual forms that we can do. So to do this, the first advice that I would have would be to find a good component library. So for example, Material UI, React Toolbox, Blueprint, or for React Native Paper, React Native Elements. I forgot ton of them, but the idea is that I don't want to start from scratch because I have enough to do to rebuild the whole interface. I might as well start with ready-made components. You just want to be sure that you have an extensive list of high-quality components, good theming support, accessibility, and a good documentation quality. I've been using Material UI because I'm again on desktop. It's a desktop application, and it had the most extensive list of components that I was looking for. Then the first challenge that I had was I wanted to display a large list. By large, I mean list containing, for example, hundreds of objects. So in your game, you can have 100, if not maybe 1,000 of objects in your game. So the solution for this was to use virtualized list. So for example, using React Virtualized and React Sortable HOC, you can go from one list that is just displayed by iterating on the list of objects to a virtualized list. So that means that only the objects that are shown on the screen are living in the DOM tree, meaning that instead of having thousands of DOM elements in memory that could make the browser crash or be slow, you only have maybe 10 of them. So it's particularly something that you can really see. You can really see the difference on mobile. So to use them, it's actually pretty easy. You wrap your list in the list component that is offered by React Virtualized, and you pass the row renderer, which is a function that will be called to display each row that is displayed on the screen. And then, using React sortable HOC, you can get a list that can be reordered by wrapping again the list in a sortable container and each row in a sortable object row, in a sortable element. So using both of them, you can get a list that is both virtualized and you can reorder. So that's exactly what I wanted. Next change was that I wanted to have panels and resizable editors. So as it's a game engine, people like to customize their workspace. They want, for example, to move the property grid that is on the left to the right of the screen, or even to another screen. So I was looking for a solution in the React world, and turns out that you can use tiling window libraries, like, for example, React Mosaic. So just try it. It's super efficient, and basically, out of the box, you have windows that you can move on the screen. Internally, it's using React drag and drop, and it's super efficient. Next change that I had was to be able to display large trees of components. So on the left, you can see the native version of the events that are describing the rules of the game. And it was done entirely manually. I was drawing every rectangle and drawing the text. I think it was a 2,000 line of C++ in my table. And then I was looking, okay, maybe I can do it better using the components approach of React. And for this, turns out that virtualization was again a solution using this time React sortable tree, which is basically doing what I want. It's displaying a tree of nodes that you can reorder again. And the interesting property is that as I have thousands of events in a game, I want to be able to virtualize them so that I have only a few events to render on the screen. And the way it's done is super interesting. It's using React Virtualized again to only show, every node that you see in the tree is a row of a list, but there is no real tree displayed on screen. The lines that you see on the left are just fake lines to make it look like a tree. And I think that the most advanced thing that I wanted to do was to display levels of the game that can be quite complex, thousands of objects again. And here the thing is that we can forget the DOM. It's not efficient enough. The answer might be to be using WebGL or some library, like, for example, Phaser or Pixie.js if you're doing 2D rendering, or 3.js for 3D rendering. I've been using Pixie because that's the rendering engine that I'm using for the games. So I might as well use it for the editor. Still, sometimes the DOM can be good enough. So let's say that you have here I have an editor when I'm displaying an object of the game, and I want to display the collision mask. That is the area when you touch it, then the object is considered as being in collision with your cursor or another object. And here I've been using SVG because actually it was easier to display using SVG the collision mask rather than going with Pixie.js or another WebGL library. And in fact, it's even really nice because using things like onPointer move, onPointer up, and onPointer down, you can allow the user to drag and drop the vertices of the polygon, and so it's a visual editor. So that's exactly what I want. Sometimes things are not fast enough, and I think the first thing to consider, it's either React or React Native, it's the performance of the rendering. So there is something really useful since React 16.5 maybe. It's the profiler that is built in the debugger. And so if you've never used it, the idea is that everything that is displayed on the flame chart and that is colored is a component that has been re-rendered while I was recording the session. And I had an issue where when I was closing the project manager. So the project manager, it's a list that is on the left of the screen, and that displays the structure of the game. And when I was displaying the project manager, when I was closing it, the whole application was slowed down for 1 second. There was a lag of 1 second. And it was because the whole application was re-rendered, because the project manager was more or less at the top of the tree, of the tree components. Of the components of tree, sorry. No, of the tree of components. Anyway, the whole application was re-rendered, and the solution here was to use should component update or memoization, so that you're sure that when you're doing some operation in one component, it's not affecting the other if the component is at the top of the tree. Also, be sure to measure performance in production, because the development build of React is way slower with all the warning and the checking that are done. So yeah, be sure to be running it in production to be sure that you're not debugging something that is already fast. Make sure to inspect also the calls to WebAssembly, because there can be some overhead. So again, in particular, that will be noticeable in particular on mobile, because imagine that you're iterating on a list of objects, and for every object you're calling a method, for example, getType and getVariables that are WebAssembly methods. Then every time you're paying for the cost of translating the parameter from JS to WebAssembly. And I think that this has been fixed in Firefox, but in other browsers, you still have some overhead when you're calling into WebAssembly. So it won't be noticeable for most of the time, but it might be a good idea to store things like values or result of computation inside the JS world, so you can iterate on them without going through the bridge between JavaScript and WebAssembly. At some point, your code base is growing, and things are starting to be harder to maintain. So here are a few tips that I found useful in my project. The first thing is to stick to your component. I mean, for example, if you have a help button in your project, you might at some point change the help button so that it's smaller than other buttons. So you could add a style to it, and you're done. Basically, what I'm saying is that instead of doing this, create a help button component, basically have a design system, or bring a design system in your project and stick to it. I try to do most of my components without a single line of CSS, because I just want a bit of CSS to customize things that are coming from Material UI, and that's all. I would say not to unit test your visual components. Well, actually do, but only if there is logic that you really want to test in it. And even if the case, maybe you should move it to a hook then that you can test. I don't have a lot of unit tests for the interface, but I have something else. It's a lot of visual stories. For example, using Storybook or React Style Guide list. In my example, for almost every component that I'm doing, I'm creating a story, meaning that I'm able to test and develop this component in isolation of the rest of the app. And that's really useful when you're coming back at your application. Let's say that you're upgrading your core component, like a button, or that you're upgrading to a new version of Material UI, in my example, then I want to quickly check if every single component is working. And using a Storybook, here I have a list of components. I can quickly iterate and see where are the bugs that will not be caught, I guess, by unit test. Last thing will be to use types. I'm a big fan of types, whether it's Flow or TypeScript, because I will tell you that you forgot to remove something, or it helps for auto-completion, it avoids the most silly mistake that you can do, it helps to document, in a way, your objects. All of these are really useful when you're back on your module or when someone else is working on your code base and that you want to help them or help you later. In a way, types are really shining when you or someone else is working or refactoring part of the application. And after a few months, you're a stranger to your own code base, so it's very useful to have types to tell you, you refactor this component, fine, but you forgot to update a prop on the other part of the application that you don't even know. So yeah, that's a cost when you're writing, but then it's a big win a few weeks or months later. So I think that we have the C++ code base now working with WebAssembly. We have the JS code base that is now written using React. And the last thing that we need to know is how to package all of this. We can make a progressive web app. For example, there is Kush.app that is an open source app that you can use, that you can try, and it's using WebAssembly. You can use Electron, and we can even use Chrome Embedded Framework to embed this into an existing application. Just want to say that it's a good idea to take a look at Electron APIs, in my case, or at native APIs if you're using something else than Electron, to rebuild some abstraction over the things that you can. For example, the context menu. It's much better to show a native context menu, in my case, rather than a material UI, the context menu, because I have a desktop application. So yeah, let's see the result. So I'm going to demonstrate the same thing as before, but using the new software. So I'm creating the button, and so all of this is the new software built on Electron, Material UI, React, and WebAssembly. And here I'm creating the button. I'm renaming it and adding it on the stage. And then I will be doing the same thing as before, creating an event so that when the player steps on it, the button is pressed and the platform goes up in the air. So you can see it's mostly the same thing as before, but new and updated. And all of this is running, so the whole interface is in React, and everything that is related to the game is using WebAssembly to use the existing code base that I had. The advantage is by doing this, I have the exact same features than before, and the backward compatibility with the old version of the software is almost perfect. So now that I'm done, I click on play, and same. The game is compiled to JavaScript, and it's working. So I just want to finish by saying a few things about my users. Are they really happy with what I've been doing? I'll be honest, for the first version, they weren't happy at all. Not because it was using Electron or React or Material UI or whatever. They weren't happy because I was missing a lot of features that I had before in the previous version. Because I used WebAssembly to port the native code base, but I still had all the interface to redo on the top of it. But after I would say 1 year of work, they started to say, okay, actually it might work. It's maybe even better than the previous version, and they can feel more productive using this new version than the old one. So just want to say it works. It works. And I think that not only it's working, but it's better than the native application. I can iterate on it really fast using the storybook and using JavaScript or to reload. I have a near-perfect cross-platform. I have faster startup time, auto-update, more contributors. I can try it online. I can even run it on phones. And that's great to have a game editor running on a phone. It's not really usable, but I'm working on it. And I think that's all. Just ping me if you're on Twitter, if you're working with WebAssembly. I really think that we'll see more and more applications using WebAssembly and front-end frameworks like React. Check gdevelop on GitHub. And yeah, the last thing that I wanted to say was that using web technologies, we can now do websites, mobile application, and in general applications that are now better than what we used to do in the native world. Thank you.